goobers? Full body tracking does not want to work right now, so I guess we're gonna be in like iPhone only mode for a bit. Hold on, let me go plug it in and charge. Okay. We're charging now. Cause the face tracking definitely blows up the battery. Yeah. What's up, goobers? Yeah, today I guess we're going to be prototyping the smart armor for injection. Yeah, I just got back home like really recently, like only 20 minutes ago, so it's been kind of a rush to get this set up, and then SteamVR just doesn't want to work right now, so I guess I'm just gonna have to like awkwardly move my phone between the workbench and stuff. Yeah, probably gonna do workbench stuff. I don't know, I kind of want to give it more shots, but at least while on camera, so that like the stream doesn't look dead, because it's actually kind of really important to like get the automatic moving zones working and stuff. Also, if I move around too much, then like I lose tracking, like this. Okay, I guess trying again. Whoa. Okay. So that's not full body tracking, that's just my iPhone going like really far away. Let's see. Let me try putting some of the trackers on. Steam VR, why are you doing this to me? Let's try restarting Steam VR one more time. That means that I'm gonna disappear. Okay. Guess I'll try putting on the other stuff right now. I promise I'm still here, even though the screen's like black. I wasn't talking to you. Okay, tracker, full body tracking. Why am I like stuck here? It's, okay, what happens if I change scenes, at least? Yeah, that's kind of creepy. I have no arms, apparently. Is it like stuck on some menu? Because it does that sometimes, but not all the time. Turn to game. I'm gonna be like really annoyed if like the controller binding just like died or something. Doop. Okay, just tracking mode. Oh wait, maybe my UI was flawed the whole time. Wait, no, it's not, because I didn't actually turn this part off. Oh wait, Steam VR has encountered a problem again. Okay, let's reboot it again. If not, we're just gonna have to do everything manually, which is annoying, but whatever. Okay, Steam VR is turning back on, and what about Pearl graphics? Doop. Y'all can hear me, right? Okay. Let's try this again. And it is concerning that, okay, so it does see my controllers, or my trackers at least. Okay. Well, we're gonna screw that for now. set it to iPhone only tracking mode, and take all of my funny accessories off. Okay. So, yeah, I guess, oh my gosh, my hair is going nuts. Whatever. Yeah, this is just a really bad technical difficulties day, but anyway, okay, so we're designing smart armor for injection. Yeah, this is seriously really weird. Oh wait, what if... Okay. I think that fixes the hair. Okay, there. Alright, so smart armor. What is smart armor? So I was talking about this in the, what was it called? The brainstorming sessions, and also in the video for, Injections Electronics. And so smart armor is like, the idea is having telemetry on the armor, like being able to know the live status of the armor on the robot, if it's like broken or not, or if it's been like pierced, or if it's just been like completely taken off. Like, as if you can just look at the robot itself and know, but it looks cool and stuff, so I want to do that because it's fun, and it's like in all the like anime and video games that have like giant robots and stuff, and then you see like the status of like different parts of the robot and stuff. So yeah, we're gonna be doing the necessary R&D to actually get that feature working. Okay, let me open up KiCad. Oh, I haven't opened it on this user account before, so hopefully everything works. Because, yeah, I made a new user account on this computer. And I'm still getting used to things a bit on it. Documents, KiCad, projects. It is where I thought it'd be. Okay, cool. No, I don't want to check for updates. Oh my gosh. Okay, I'm just opening stuff right now. Okay, looks like everything works. Okay, let me go switch it over to, this view. Let's share the screen. Oh, I want to hide that. Where's the projects bar? Okay, hiding you. Okay, screen. This is oversized. Transform, fit to screen. Okay, cool. Yeah. So, this is the PCB for injection, and actually this isn't what we want. We want the schematic. Okay. So, the smart armor feature on injection uses the ADC. The ADC is, it basically can just read voltages, and it's like a separate part from the ESP32. And we're actually already using it in two areas of the robot in order to measure the current battery level. We're using one of the channels on the ADC. Has 8 channels, so we can read 8 different voltage readings from it. And I wanted to put it on a separate ADC instead of use the analog pins on the ESP32 because I was already using a lot of the pins on the ESP32 since it's like a tinier version of it. And I also wanted something that was like kind of separated out, just so that like if we accidentally had like a power surge or something like that, if we overvolted it or something, then it might protect the ESP32. I don't know. I think it helps. I want to think it helps. But yeah. Let's see. I should probably get the parts out. Where is the robot? Well, we don't need the robot right now. We just need the parts. Okay, I need to like dig out the robot parts from this doom pile right now. Okay, so and my avatar is just gonna go absolutely nuts today. Does that work? Still? Yeah, I guess it does. I have to like change the camera manually. Or wait, yeah, we'll just workbench. Alright, I need to turn the GoPro on. Okay. Honestly, I think I'm just gonna disable my avatar because it's like a huge distraction today. Yeah, okay, so the part that I'm talking about is, this part here, and that's the ADC, that's a separate, voltage reader, and I have, 6 inputs here for 6 different armor slots, and, I also have, you can't see it, because it's like underneath stuff, but there's 2 voltage dividers so that we can get the readings of the voltage that's powering the ESP32 so that we know if it's like dipping for some reason and causing brownouts, and voltage from the battery directly, although it's voltage divided so that we don't like overvolt it and burn stuff out. And so that's already in use right now. Let me get my Steam Deck. Hold on, I think my Steam Deck's in the bedroom. Let me go get that. Okay, I am back and have my Steam Deck, and let's see, power. Let's go switch to desktop. Might as well keep this charged. So, what am I doing now? I'm gonna be opening up the control app, so that we can see it. We might have the voltage values, I'm not sure. If not, we're just gonna have to go to the Unity editor. Where is my keyboard for that? Okay, there's my keyboard in case you have to do that. Sure is taking a while to launch. Today is really a technical difficulties day, I guess. But we're getting through it. I probably need to get the, control backpack thingy, too. Oh, here's one. Come on, load. It has actually never done this before on me. I'm surprised. I'll just see if, like, paracycling it and trying again works. Okay. Yeah, that is one thing that kind of sucks about using the Steam Deck for robot combat stuff, is if you need to reboot the controller in the middle of the battle, you're completely fucked. it's gonna take way too long to do that. So you just really should have something stable enough that it will never crash and you never have to reboot it while you're doing stuff. Okay. Still waiting on that. It has never hung like this before. Doop 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 doop. Okay, that's not normal. Okay, if we can't get that working, we should be able to get it working, though, from the Unity project on the computer I'm streaming from. So maybe let's try that for now. Okay. Let's see. Turn that off. And then Unity, I'll probably have to log in on here. And I forgot what my Unity login was, probably. And the Steam Deck is still going. It is still churning. Okay, what is my... Probably... Nope, that's not it. Okay. It's not that one. It's not that one. Okay, what is my Unity account? Hold on, I need to look that up now. Password manager. Oh, okay. There we go. Now I'm logged into Unity. Okay. Need to add project from disk. I'm intentionally not showing my screen right now. By the way, I'll show it when the project opens. Unity projects. And yeah, this Steam Deck has never frozen like this on boot before, so that's really concerning me. Is it... What is the build that I use for this? Hold on. Okay. That's what it is. Okay, gonna go try power cycling this again. But yeah, I've never had it freeze on boot before, so that's concerning. Okay, I think the Unity project is launched at least, though. Just need to get a micro USB cable. Oh, it's working. Okay. Let's try. Oops. Switch to desktop. Okay, there we go. Now it's working. Alright. So, let's see. The voltage out yet, so that needs to be changed. Or we need to, I guess, just load the Unity project then. Unity. But we can also do that on the Steam Deck itself. Okay, sign in. Gonna hide that. Wait, is this thing on? Let's see. Steam Deck. Is it not paired anymore? Keychron K6 Pro. Okay, it looks like it's not paired anymore for some reason. Okay, no, fuck. Okay. Found a... Wait, no, that's not gonna work, because I need C to C cable. Did the Unity project open on this side? You know, it did. That's gonna be easier to work with. Okay, so let's not use the Steam Deck. And, let's go back to here. Or turn this screen on. Okay, there we go. Need to find like a free USB port. Is there one behind here? Yeah, there is. Okay. Now we have the dongle working. Okay. So this is the Unity project for Injection's control app. And we're just gonna modify it so that we get the telemetry display out on the side here, which we just need to oh my gosh, I don't want to use you. I want to use Ryder. Ryder. Doop, doop, doop. Open with JetBrains Ryder, please. Okay. Cool. Alright, so where do we have the telemetry display at? Telemetry display. Telemetry state, I think. No, I didn't want you, Visual Studio. Telemetry values. Okay, we don't actually have the smart armor values being saved yet, so we need to fix that. Battery voltage. Telemetry state. Oh, we are saving that. Yeah, it's been a while since I touched this for. Okay, so we are saving that value at least. So I'm just trying to make sure that we're actually getting the telemetry value out of the robot at the moment, and that might be here. But we need to turn the robot on too and connect. And I think there's a thing here where like the USB device name isn't the same thing between like Unity and Windows. I think it's just like COM0, COM1 or something like that. So yeah. Oh, is this even updated to like the latest one? Collapse. No. Okay, I need to change that so that we just open Rider by default instead of Visual Studio. Because I don't use Visual Studio, but it forces it to be installed anyway, I think. Preferences. General? External tools? Yeah, there we go. Alright. There. Trying to find the thing where we have the serial ports named and stuff. Might be in here. Might just be COM, I think. Nope. Where are we setting that? I think because we're saving it from something, we might just need to like overwrite it there. Input string was not in the correct format. Okay, so it doesn't want me to increment that. Okay, there. Now we can try that. Ooh. just crash? I think it did. Oh, no, it didn't. It just hung for a bit. Maybe it doesn't like COM3. Okay, let's do device manager. Let's see what that ESP32 is. It might be COM6. Yeah, it's COM6. Okay, cool. So, I can tell because, if you go here, that's now blinking, and if I press the reload button again, then, yeah, it changes status and stuff. Yeah. Okay, so we are now talking to the dongle thing, and so I think if we just plug a battery into this, and then... Where's a random ass battery? Actually, let's not use a battery. Let's use the power supply. Okay. I guess we're gonna spin this. Oh. It's because that's not plugged in. Does that do anything? It's not doing anything. Let's try, like, an actual battery now. Where are my real batteries? Okay. Yeah, that's power to that. That's concerning. Nothing's powering on. Is this a dud? Let me go get the other robot. Okay, so here's injection. And, getting the weapon safety locks, because she's scary. Or, at least, let's just get it for the disc, since that's, like, the scariest part. And then, I don't know if she already has a battery in her. Okay, she does not. That's good. Doop, doop, doop. Okay. Let's open her up and pop a battery in there. Okay, opened up. Plug in a battery. Okay, now we have a working robot. And if we go back to the app, to the Unity editor, and let's reload. Okay, cool. We're getting actual values out now. Okay. That took longer than it should have, but we got it working. Okay. So I want to see if we're getting the smart armor values, which we are. That's good. Yeah, you can see it here. It's just not being displayed here. So I want to display that there, though. So I'm gonna modify the code a little bit so that we can actually show that out. Not telemetry message. Telemetry display controller, I think? Okay. Plus Smart Armor 1. /n, new line. Cool. And then telemetry state dot smart armor health 1. Two, 3, 4. Okay. Oh, I want to add some new lines here also. Just to separate it out. Okay. That's overlapping and that's pretty ugly. And we want to format that number, so let's call it Armor 1, Armor 2, Armor 3, and let's format this to, is that the correct thing for just 2 decimal points? I mean, we don't even need, like, 2 decimal points for this, because, yeah. Okay, reload. Format was invalid. Okay, these numbers will work for now. Alright, so now we're actually displaying the, armor values, on here. Or the readings in some kind of way. But those numbers are kind of arbitrary. Because, what does it actually mean? So, it's like a percentage thing, and, sea lion. Let's open up the firmware for her, for the robot itself. Hide the screen for now. Where is the file for that? Where did I put her firmware? Firmware, where are you? It's not Pearl Graphics. Okay, that should be it. Let's show that. Yeah. Okay, so smart armor. It goes from 0 to 255. And where are we converting this? Okay, so if I'm remembering correctly, the reference voltage for the ADC is going to be VREF is going to be 3.3 volts, and what does that mean? If so we're storing that as a percentage of what the maximum reading could be. So if that's a float representing the percentage of the reading, of the maximum reading, and then we ship that off to as a telemetry message. Message. Okay, then you just multiply it by that, and then that becomes a 1 byte number. And then comms manager to parse that. Just divide by that. Okay, so that is a percentage of the maximum reading then. Where is my multimeter? Multimeter, I think you're in my backpack. Yeah, you are. Are you? Yep. Okay. So, I think that means that, if we were to measure the voltage, let's see, I think that that's ground. And then it's A1. Oh. Something came out. I think I just burned something out. Yeah, I think I just released magic smoke from this. Damn. And I forgot to change the camera, so can't even get a clip of that. like smoke came out of this bit, at least. I really hope we didn't blow up the rest of this board. We could probably figure that out just by, like... I think it's dead. Oh, shit. Yeah, actually I have no idea what to do right now if I just burn this out and if my other boards don't work. Might have to put this project on hold. It was that same part that also smoked out on the other one. Wonder if these are shorted now. Huh. Yeah, I'm still thinking. Okay, that's interesting. That board works if we connect it directly. Is this one just totally dead? Yeah, I think that one's just dead. Oh, well. Yeah, I'm not sure how we got that kind of reaction out. Let's see what happens if I desolder this, and then just try plugging it in, and if it still works. Something smells weird, but it's not from here. I think it's from the kitchen. Okay. Let's get the big desoldering gun out. Because the best case scenario is that it's only the buck converter that's fucked. The worst case is that we blew up the entire board. Okay, that should be getting hot pretty soon. Gonna inspect this for more damage. Because, yeah, that's definitely nasty right here. If he can see that. I really hope that we can salvage at least some sensors and stuff, because this wasn't that cheap. Okay, that's probably hot enough. Okay. That should be removable. Yeah. Okay. So, what happens if we do plug this in now? Oh, you know, it may not be fucked after all. If we plug in the LEDs and it does cute LED things, then there's a good chance that it still works, and it's just the it's just that buck converter that needs to be replaced. Oh my gosh, it works. Okay, I'll take that. Yeah. Cool. Okay, that's a way better case than it could have been. Alright, so I need to figure out what... Does the ADC require the... Let me check if the ADC actually requires, the battery at all. I don't think it does, because we're getting 3 volts out from the, ESP32. I guess that we can just, hook this up to USB power, and let's get this out of the way because it's nice and toasty. Let's just hook that up to USB power, and see if we can connect to it from the dongle thingy. Because if we can, then we are back in business. Okay, where's my dongle? What's up? Wait, why is this not... Did I kill that USB port also? I may have. Shit. I think I killed the USB port on my framework for a bit. That's not good. Since I'm not doing full body tracking right now... Yeah, that port's dead. I really hope it's got like a resettable fuse or something in it. Okay. Yeah, it's the, what's the number on it? It's the, Hakko FR301, and it's super duper duper convenient. Let's see. Okay, back on the Unity project. Let's reload. Yeah, we are actually, yeah, we're connecting to the robot again. And, we're getting those readings out. I just have to be careful not to do that thingy again. Okay, that's stressful. What next? think I'll stay in schematic land right now. Let's see. Actually, we should probably confirm what those pads were. Because I must have shorted something. Well, ground to an ADC pin should not cause that. Not sure what happened there. Especially because it's just a voltage reading also, unless I accidentally shorted the two. But still, there are like resistors from here to here, so that shouldn't have done anything. Okay, let me see if I can do like a weird combined view. I don't know why Bamboo Studio is showing up here. But let's put the thingy up here. Display capture. Yeah, that. Okay, so I guess I wonder if I accidentally shorted it on the back of the board touching something. Shorted something out. But anyway, we could just use ground pins that are not, you just use ground pins that are like not right next to the ADC pin that we want to test. So let's see. The ground ones are the funny square ones then. Oh, that's continuity test. Okay. Here, yeah, we're getting 3.3 volts. That's what we expect. And, I guess I'm gonna see what happens when because when we short two of these together, we're just supposed to see, one of those numbers drop for the smart armor thing. So let me go get some tweezers for that. If these are conductive. I think they are. Okay. So yeah, when we short that, that means armor's set to 0. And then when it's open, then armor's like 70-ish. Those are kind of arbitrary numbers, so we actually want to flip that around. Although I do wonder why armor is like reporting at like 70-ish, not 100-ish. It's a bit weird. But, okay. We have a baseline thing going. So, things have been pretty abstract right now, just as I've been trying to figure out what the hell is going on with all the tech going wrong. But, now I think we're actually at a stable point to start experimenting. And if I pinch those values, then, yeah, that also goes to 0. That goes to 0. And this goes to 0, and that's exactly what we want. So the idea is, let me go get a piece of like armor or something from the robot. Come on, we're just a random piece of TPU. So the idea is, I'll just grab the robot itself. we want to have a wire embedded inside of the armor, and then have it loop around into here and plug in. So that, let's just pretend that's plugged in. So let's say that this loop of wire is inside of the armor, and then like it gets like slashed open or something, and then this wire is cut, and then we see that go from, it's currently 0 to like 70, and we want to flip that value around. So yeah, I guess that here we could kind of like hack that in. So here, oop. Okay, let's rewrite some of that code, I guess. For now, we'll just say that if the value is like over, say, 69 or something, then the armor is connected. If the value is not, then if it's below that, then it is connected. If it's over that, then it's disconnected or damaged. So yeah, let's go to app view there. And this is gonna be like really shitty code, but just prototype, so it's okay. Var smart armor status text 1, or smart armor 1 status text is equal to healthy, and let's just copy that for all of those. 2, 3, 4, and then if armor health is bigger than, like, say, 67, then we'll say that smart armor is equal to damaged. And then we'll just do that for the rest of them. Go, Copilot, go! And then we can replace all of that. Not you. Okay. Let's see what happens here. And I'm gonna go use the bathroom real quick. Okay, I'm back. Alright. So yeah, if we go back to the workbench view, and I guess zoom in. I don't know why that zoomed out. Okay, there. Yeah, then we can see that it reads healthy, and when it's unplugged, then it reads damaged. And that's exactly what we want. So that's the most basic case of the Smart Armor. Alright, so we don't just want to know, we don't just want to know if, like, it's damaged or not, we kind of want to know how damaged it is. So with that, should probably figure out what size the resistor should be, though. So, let's go sketch it out. Where is the app view? Air server. Let's try that. I hate it when you, like, type something in, and, like, you're trying to search for something, and then it's like, oh, if you type in the rest of it, then we're actually gonna give you a different result. Okay. Setting up the iPad screen mirroring. Alright, cool. Yeah, that works. Okay. Let's see. So, if we have, the pull-up resistor on that is, okay, so, ADC input, and then this is 3v3, and that's 22K. So instead of having it so that we have a direct connection to ground that gets, like, broken or not, I think we want, like, I think that we want, like, a resistor network. And so, with that resistor network, what was the formula for parallel resistors again? Parallel resistors. Oh yeah, so it's 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc. And so let's say we want to have, like, 4 different sections of armor that we test out. Then that would be 1 over 22 is equal to 3 over R. So then if we solve for that, then should get 66K. Oh no, why did I pick 3? Oh, that's because I didn't write out the whole formula. So then that'd actually be like, or if we want these to all, like, be the same. So I guess that's gonna be 88. Should I already go with that? Let me go get a breadboard. Where are my breadboards? I have, like, so many breadboards. Here's a breadboard. Okay. Do I have 88K? Is that, like, a common thing? hope it is. 220. It's not in there. Shit. I guess we could just test it out with, like, just... Okay, 47. Could I have missorted it? You know, let's actually just do maybe 100k. And let's do, like, 5 pads, I guess, into that. So... Okay. There's a bunch of hot glue. 1, 2, 3, 4, 5. So it's all gonna be going from ground. So let's stick that in the ground pins. Yeah. We can actually simplify it by just putting it all up in there. Because every time a resistor gets damaged or taken out of the circuit, basically, that should make the resistance go up on the parallel resistor network. And then that will make the reading move up and down. No, actually it's easier if we just do it like this. And then, like, just jump it a few times. Oh, we don't even do that because these, like, resistors are so skinny that you can actually cram multiple leads into one hole. Yeah. Okay. And then you can just solder it to there. There is some wire. I'll just use solid core wire. Let's use black and yellow. Yeah. Okay. Some yellow. I watched a video on, like, every single function of, like, of wire strippers, and it was really cool. I'll have to find it and, like, post it somewhere. Post a link to it on my social, just since there's lots of stuff that soldering iron can do that, not soldering iron, wire strippers can do that I don't think people realize they can do. I didn't realize that they could do that stuff. Okay. So we're just gonna disconnect that. And then, let's see, I'm gonna just be lazy actually and just pop that directly in there. And then pop. This might be more work than actually doing it the correct way with the OmniFixo. Okay, whatever. Plastic. Okay. Why is there a giant ass welding magnet there? Okay, that's hot enough to wipe off. examine that, just make sure, okay, it's not shorted, that's good. Okay, so what we can do is we can simulate the armor with this breadboard here. Let's plug this back in. Okay. Cool. And then we can go back to the software. Wait, what? Why did air server stop? Whatever, it doesn't matter. We're not looking at that right now. Look at Unity. Okay, so let me just copy this display into here. Let's reload. What's it called? We can get kind of like more of a gradient of what the health of it is. So how's that look like? Okay, so if the top is like, let's just say that 0 is perfect health and 70 is fully destroyed. So then we just want to map that so that yeah. So we want like a percentage of the health then. Okay. That means that, there's like a, what was it, math.math. I am blanking out. Okay, float, smart, armor, 1, health, equal to, is it going to be that? Divided by, why can't I think right now? Because I'm on stream. No, it's not that. Does that seem right? Times whatever that is. Okay. So let's see what that does. That's not correct math. But if we start plucking resistors out, we should see it change though. Yeah. Okay, so in that case, we just need to get the math correct. Okay, so let me just do this. Okay, so destroyed minus not that minus telemetry state smart armor health 1 inverted. Yeah, okay, that makes more sense. Destroyed. Okay, so in that case, we have that. Okay, let's see if that actually does what we want. Although, wait, what was... Oh, it's because we also messed with the resistor values anyway. So, you know, actually that may be what it's supposed to be. Hold on. Because if we had... What were the resistors that I grabbed? 100k resistors? Okay. Air server. So that's gonna be 5 over. Oh, okay, I know what's going on, actually. Because that's lining up to about 20k, but, we need to get... Tell me straight. Telemetry state.smartarmor 1. Let me get what the raw value of that is first, actually. Why does the scale keep resetting on this? Okay. So that is the raw value of that. So it hangs around like 40-ish at full health. Let's go to the workbench. If we start pulling out resistors, it goes up to 45. 50-ish. Let's pull all of them out. Okay, so 70-ish is when it's like fully damaged or detached. And should probably add like a filter to this or something, or a rolling out average, I guess. 40 is when it's complete healthy. So I think we actually want to do minus perfect. Minus perfect. That could be what we want, I think. I'll just copy this here. It's a -%. That's not what we want. Okay, let's just work backwards. Okay, so health should be... Okay, so if we start with telemetry, smart armor, health, whatever, and then if we subtract perfect from that, then we move the floor down to where there's like 30%-ish that it moves, I guess. So I think that's destroyed minus perfect. Divided by that. And then ideally we should have it show 30, I think. It's gonna have a percent thing, but that's okay. Just make sure all of those are plugged in. Don't think they are plugged in. Okay, I think that actually might be the correct one, then. Let's try that. Oh. Wait a sec. I forgot to fill that in. Smart Armor 1 status text. Okay, cool, that's what you want. So maybe we can just tweak the values a bit so that maybe perfect's more like 43 or so. And I think there's also going to be an issue where the curvature is not going to be linear either for the health. Okay, so we show 100% health. Actually, let's just get rid of that first. That first readout. Okay, so we're showing 100% health when all 5 resistors are part of the resistor network. And then if we pull one of them, then we get 92%. We pull this one, and we get like 70-something%. And so that should probably follow some kind of curve. I don't know what curve that is though. If almost all of them are pulled out, then it's really low, and then when all the resistors are cut off, then we have no health on that armor piece. So yeah, that's the proof of concept. So the idea is that, like, we'd make armor that has, like, the resistors, or, like, the traces connected to the resistors embedded into it, either, like, into the 3D print, or into, or, like, we have a PCB that also is being used as armor, because FR4, which is PCB material, is very similar to Garolite, which we use as robot combat armor. I think it is actually the same thing, because it's like fire treated also, just because it's like used for PCBs. So could use that as armor with traces embedded in them, just like super duper simple SMD resistors, and then we have smart armor that detects how damaged it is. Yeah. Okay, why is that something's not fully connected? That's like, there we go. So I think just need to figure out what curve that is. And, okay, so if we remove one resistor, then we get like... No, that's not it. Because I unplugged like another one by accident. We get like 92-ish%. If we pull out another one, then we are at like 76-ish%. We have only 2 left, then we're at like 55%, and that's not really proportional. And I want to get this so that instead of doing that, it's something close to like 80%, 60%, 40%, 20%. So let me just plug that in and figure out what the best fit curve for that is. We're just gonna use good old Chatty G for the best fit. man, we could also just use text for that. Well, I was thinking that, like, if we hide the settings, we can actually show the armor status by, like, the color of the different thingies on here. Like... Oh, wait. I'm not showing the screen. So, like, this is white right now, but, like, let's say the entire robot is, like, kind of dead-ish. Then, like, well, there's, like, a purple filter on everything, so it's not showing up that well, but, like, I think you get the idea. Like, this would be a fully healthy robot, maybe just have it at white, and then it just slowly turns to red, depending on how damaged it is. And then it could just be, like, black if it's just disconnected or just offline completely. It could also go, like, a white to yellow to red gradient. Yeah, that'd be cool. Okay. Okay, got silly function out. Yeah, that might make it linear now. I think that's like the opposite of what we want. Oh, because I think all of them are taken out or something. Nope. Well, I mean, like kind of close. $75. Okay, yeah, that's kind of close, I guess. Okay, yeah, I guess that is actually closer to linear then. So, if the armor has all 5 resistors in it, then we're at 100%. You pull one out, we're at 75-ish. I mean, I don't think we're going to care about the actual numbers. I think we just want, like, a cool color. And then, if we pull another one out, or maybe pull out 2 of them out, 50. 20. And here's, like, just barely hanging on. And then completely disconnected. Yeah. Okay, cool. Well, yeah, so I guess that we kind of have the proof of concept for how smart armor works then. Not gonna lie, I feel like today has been pretty cursed with technical difficulties, so I think I'm gonna go end the stream a bit early. Plus, can't really think of what else to do now other than expand it to the other ones and do a 3D print. That'll take a while. So I guess next time, or I guess whenever I schedule the next session, it'll probably be an integration. I think we're done with R&D. This is a pretty quick R&D session. I guess when we do the build session for the smart armor, the 3D prints will probably be ready to go, and then we can just embed wires into them and solder it up and see what happens and wire it up in the robot's UI instead of just getting these percentages. But yeah, I wonder what we want to show for, like, the armor integrity, because, like, how many ports do we have? Because we have, like, 6 armor ports, and I'm thinking that, like, we could probably have it for, like, the left side, right side. Okay, so that's left side, right side, front, back, and then top left and top right, I think makes sense for injection. Just with how she's designed with, like, okay, so the right side and left side, then front, and then back, and then top left and top right. I think that makes sense. So, yeah, I'll probably need to expand the firmware out to also show 6 armor zones instead of just 4. But yeah. Alright. Well, let's see. I guess I can use the avatar for a bit. Face cap. Doop, 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 doop. Come on, loader ready. Loading. Okay. Alright, yay, my avatar's back. Well, it was back. Screw it. I'm just gonna show it on here. Alright, so, I guess on Thursday, I'm gonna be streaming, some R&D on the PCB, on turning the macro pad into a PCB, and then, on Sunday, gonna be making the forced hydration machine thingy. At least the R&D for that. So, yeah. Alright, I guess that's it for the stream. Logging off, bye!